In this video, I'm going to show you guys how to do something called factoring. We're going to be strictly working with quadratic trinomials. So for a reminder of what that is, a quadratic trinomial would be something like x squared plus 5x plus 6. And through your module, you should have been doing something called riddles, where you might have been given a question, two numbers, have a sum of 5 and a product of 6. What are they? And if you look up at your quadratic trinomial, you're actually going to see your 5 here and your 6 here. So your 5 is in the place that we usually recognize as our b value, and our 6 is our c value. Now we don't actually have a number here in front of x squared, but technically there's an invisible 1, and that represents our a value. Just looking for my other pen. So this would be our a value. So you would usually go through that. The way that I like to do it is I like to pull out my c value, which is 6, and I like to think about all of the factors that I have of 6. So I could multiply 1 and 6 together to get 6. I could also multiply the opposites of that together, so -1, -6, and I'm still going to get 6. I could multiply 2 and 3, and I could multiply -2 and -3. So those are all my factor pairs of 6. From there, what I would want to look at is, of those, which ones would have a sum of 5, my b value. So I'm going to go through and I'm actually going to add them together and see which one gets me 5. So if I add 1 and 6 together, I'm going to get 7. If I add -1 and -6, I'm going to end up with -7. If I add 2 and 3, I end up with 5. And if I add -2 and -3, I end up with -5. So that means the solution to this riddle would be 2 and 3. So I want to go back to my quadratic trinomial, and if I've got x squared plus 5x plus 6, if I were to expand x squared, I know that it can be written as x times x. And we know that 6, if we want to get to this middle term of 5, can be written as 2 plus 3. So if I were to go backwards and I wanted to write my two binomials, I would end up with x plus 2 and x plus 3. Now, this kind of looks like I've ignored my 5 because you don't see any arrows coming down from there. But if I were to go back into my box, like we're going to go back to last week, and I place those in there, I say x plus 2 and x plus 3. If I were to then use my box to go backwards and I multiply back out, x times x is x squared, 2 times x is 2x, 3 times x is 3x, and 3 times 2 is 6. And if I pull that out of my box, I end up with x squared plus 2x plus 3x plus 6, and these can be simplified. And then that matches my original trinomial. So your goal essentially is to go from this to that. Okay, so we're going backwards from what we did last week. We're undoing what we did. So I'm going to give us another one to see if we can do that. Let's say that we start out with x squared plus 4x plus 3. So there's only one way to split up x squared, x times x. There's a couple ways though to split up 3. I can do 1 and 3 and -1 and -3. Of those two, I want to find the one that has the sum of 4. So if I were to add these together, this one gets me +4, this one gets me -4. So I would use this group. And I would rewrite my answer as x plus 1 times x plus 3. You could switch the order of these, they would still be right, so you could also write x plus 3 times x plus 1, but they would both be correct. Now let's say that we had one with some negative answers. So let's do x squared minus 12x plus 20. So again, I want to split up my two factors. X squared can be split into x times x. 20 has a lot of factors. So I've got 1 and 20, -1 and -20. I've got 2 and 10, -2 and 10. I have 4 and 5, and -4 and -5. Now, that's a lot, all right? But basically what we need to do is figure out which one has a sum of -12. So if I were to add each of these together, okay, we do end up with one that has a sum of -12, and it's going to be these two. So when I come to split up my binomials, I'm going to have x minus 2 and x minus 10. And that would be my final answer. And again, you could switch the order if you wanted to. Totally up to you guys.